This time, we will discuss about hardware. Since we're done understanding the information system with its operation and also its computer system, this time we will discuss the first computer system, which is hardware. So when we say hardware, there are two devices that we need to discuss. First, the digital device, and the other one, it's the analog device. If we will talk about digital device, this is devices that works with discrete signals such as zeros and one. Mo ni siya kadalasan ang ginagamit sa mga computers karon or mga hardwares karon. They are using digital signals. They're using digital devices na mo cater lang siya og 0 and 1. When we say 0, that's off. When we say 1, that's on. So 1, 0 or on and off or true or false are actually called binary numbers. Okay? And also if we will talk about analog device, this works with continuous data. Meaning, ang mga devices na mogamit aning analog ang ilahang signals are dili kaayo ma-determine compare sa zeros and ones. Okay? And a good example for this one, it's ang clock. 'Di ba? Ang clock naman tay analog na clock na katong gamit atong mga arms niya. And also, if we will talk about digital device, a good example for that as well is katong watch ninyo or ang clock ninyo na naay mga numbers na nag-display. Right? Those are digital signals. Okay? So we need to discuss about the digital data representation because we will more focus on the digital devices. So we need to understand this. So how can a computer represent numbers using bits? If we will talk about bits, zeros and ones are also known as bits or binary digits. Okay? The computer uses the binary number system, which uses only two digits, zeros and ones, just like what I said earlier. When we say zeros and ones, true or false, or true or false, or on and off, muna siya ang ginagamit sa mga digital devices right now. Next, a series of zeros and ones results in a particular number much in the same way we use the decimal number system. Later on, I will show you how to convert binary to different type of number systems. But just to give you an idea, when we say when we say um, 1 byte, it's equivalent to 8 bits. Okay. Again, if we will talk about one moment. If we will talk about 8 bits, okay, 8 bits, ang equivalent ana niya kay 1 byte. If it's 2 bytes, it is equivalent to capital B, ang meaning ana ha, bytes na siya. 2 bytes is equivalent to 16 bits. Ang small b kay bits. Okay? Let's proceed. Now, just like what I said earlier, this time, since we are most aware of the decimal numbers or base 10, mo ni siyang kadalasan ginagamit nato, right? Also sa inyong mathematics, sa inyong arithmetic subject. We are actually these decimal numbers are so popular to us or very common to us. But for the binary numbers, mo ni siya ang kadalasang mga mailhan kung ang tao kay IT related or ang tao kay computer related siya. Kay kasabot man siya binary. So this time, I will show you an example or I will show you an example on how to convert binary to different number system. So if we will talk about, one moment, I will put text box here. This is binary. Okay, this is binary to decimal. Okay. If we will talk about binary, please take note that our binary has 8 bits. Diba mo ito yung ganina? Ang binary kay 8 bits. So, ang binary na to kay 8 bits. So, kung 8 bits siya, of course, there should be 8 octets. Moment. So, 1, 2, 3, 4, 5, 6, 7, 8. 8 na siya 8 na siya tanan. So, if you will consider this, you need to take note that we need to start counting from the right. So, ang value aning right, sa first right kay, I think it's better ata kung padako na lang na ako ang numbers. 2, 3, 4, 5, 6, 7, 8. There. Then, kani, ang value ani niya kay 1. Ang value aning second to the right kay 2. Ang value ani niya, ang third kay 4. Then 4 times 2, it's 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. 64 times 2, it's 128. So basically, if we will compute the 8 octets, basically ang answer ani niya kay, one moment ha, I need to use my calculator. It's 255 man ata siya. Let me see. One moment. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 3. Okay, tama lagi. 255. So, 255. Okay, that's 255. Game? So, when we say kaning puwa, kay mo ni siya ato ang binary. Ang kaning blue, kaning blue, mo ni siya ang ato ang decimal na conversion. So, let's start doing the first activity or the first example. We need to discuss, for example, we have a value 1010101. Then, this should be, unsa equivalent ana niya? Unsa equivalent niya na, what's the equivalent decimal? So, ang decimal gani kay base, decimal kay base 10. So, again, let's try. Ang decimal niya kay base 10. Kana, base 10 na. Ang binary kay base 2. Okay, let's start. So, kung buto naman naon ka ni, magsugod ta sa right ha. Magsugod ta sa right. 1, 0, 1, 0, 1, 0, 1. So, it's not mandatory na 8 bits gud na siya. But if you want, you can just put here 0. But later on, just to let you know, di ba ano ko sa inyo ganina? On ang 1, off ang 0. So, ang 0, pwede na ito na siya i-cross out na. Pwede na siya dili gamiton. Because we will only consider the ones raman katong on. So, unsay value ani niya based ani sa taas. So, ang value ani niya kay, let's make it blue, 1, ang kani kay 4, ang kani kay 16, ang kani kay 64. So, if i-add na nato, pilay answer niya. So, 64 plus 16, it's 80. 80 plus 5. So, the answer should be 85 base 10. There you go. So answer niya daw kay 85 base 10. Base 10, that's decimal. Okay?